Thanks for watching the 5th edition of AI Research Weekly Update from Henry AI Labs. This week we'll cover the 8-bit quantized BERT model from Intel's AI blog, Uber's description of their Horovod, Michelangelo, and Pyro frameworks for machine and deep learning, and Google's video BERT model, amongst many other things. Thanks for watching, and please subscribe to Henry AI Labs for more deep learning and AI videos. Uber's engineering blog released 3 very useful videos, educational, about their different systems used in their deep and machine learning workflows. So the first of these is Horovod, an open source distributed deep learning on Apache Spark framework. So what this is as you go from 1 GPU to 8 GPUs, you may be wondering, how do I actually go about implementing model parallelism or data parallelism? Well, you don't have to worry about that, because you can just use Horovod's API. It's as easy as like import horovod.keras as HVD or something like that, and then hvd.init, and you just attach it to your previous model flow. It's really easy to add to your existing workflows. So overall, they talk about how they use the distributed training platform, how they're focused on data parallelism for scaling it up, which is where model parallelism would be if you have some massive parametric model, you put different parts of the model on different GPUs. But data parallelism would be you have the same replica of each model on each GPU, and they each get a different batch of data to update the parameters of the model with. So following this is the description of their Michelangelo platform, which is like overall a way of organizing their machine learning workflow and the data science operations. Things like evaluating different models and putting it into production is overall just a way of organizing the machine learning at the company. Then they talk about Pyro. Pyro is a probabilistic programming language, which is open source. So basically the idea of this probabilistic paradigm is you're modeling random variables and their distribution. So what this is really great for is uncertainty estimation compared to deep learning models that really struggle with uncertainty estimation. So if you're interested in learning more about Pyro, I recommend checking out their documentation, and they have an example for weather prediction that will help you understand this idea of probabilistic programming. Uber also posted another video about the Michelangelo system and the role it plays in machine learning at Uber. Uber also released a very interesting post on LCA, loss change allocation for neural network training. So what this is it's a metric that tries to measure how the changes in different parameters are being corresponded with the decrease or increase in the loss after each gradient descent update. So what they find is very surprising. They find that about half of the parameters are hurting the loss at a given step, and another half are helping. So there's sort of a tug of war between different subset of parameters that are trying to influence the model's prediction. So this is similar to lines of research like the lottery ticket hypothesis that finds just a subset of the network is able to achieve the same accuracy as the full network. So this metric, they use some kind of Taylor approximation in order to derive it, which, if you're interested in the full details of this, you can check it out in their paper, Loss Change Allocation. So using their metric, they visualize how the parameter updates help or hurt. They find that in the beginning of training, almost all of the parameters are helping lower the loss. Whereas as training progresses, they're 50-50 split between helping and hurting. But it isn't clear that there aren't just some parameters that are always hurting and other helping. It's like a tug of war where they're helping and then they're hurting and they're helping and they're hurting. But I think they quote something like a 53% to 47% distribution for the different parameters and their helping to hurting ratio. So you see how noisy the training is, how they have this basically like a Gaussian distribution of parameters that are helping or hurting the loss during training. So then as they further tried to utilize their metric, they tried to normalize layers by the LCA, but I don't think they find that works very well. And then they find this interesting trend where the parameters towards the beginning of the network and the last layer of the network generally hurt the loss compared to the intermediate layers. So what they do is they normalize the learning rate on the last layer of the network, and they do find a performance increase by doing this. So they suggest that the LCA metric shows that you should use different kinds of learning rates, different ways of speeding up what they call the information lag for different layers of the network. So it's overall a really interesting study, definitely a promising area to keep an eye on in deep learning research. Our coverage from Google's AI blog post begins with one of the most interesting applications of computer vision and deep learning, automated medical diagnosis. They begin their article by motivating the need for these systems by showing how general practitioners, their accuracy of diagnosing these different skin diseases that aren't cancerous ranges between 24% to 70%, whereas dermatologists have a range of 77 to 96%. So their deep learning system is going to utilize images of the skin conditions and metadata like tabular CSV style data, combining it to predict a rank order of these different skin conditions. So they're going to train their system on over 50,000 images, and as a result, they are going to perform higher than primary care physicians and nurse practitioners and on par with dermatologists. So the system works like this. They take in the skin condition images and then they combine it with metadata using a series of inception networks to transform the images, and then feature transforms, embedding layers to transform the metadata. So overall, you can see the results. They perform on par with the dermatologists and outperform the general practitioners. And then they discuss how they are trying to make sure their data set is fair and is equally representative for different kinds of people. And then finally, they show a pretty interesting chart showing how much the metadata helps improve the accuracy of the system. The green bar shows when you only evaluate on images, but you train with the metadata as well. Oh, I'm sorry, that's what the red bar shows. The green bar shows training on images only. And you see if you train on images and the metadata and then evaluate on images and metadata, you get a much higher result. So this is a really interesting system, extending the reach of, usually we've just seen these automated medical image classifiers that are only used to detect cancers and like benign, not benign, and then the different kinds of those. But this is a more extensive classifier, and it'll be really interesting to see if this study adopts the kind of neural structured learning knowledge graph system to even improve the accuracy further. Self-supervised learning and automatically learning representations from unstructured, unlabeled image data and video data is one of the emerging areas of deep learning that's primed for a breakout. In this paper from Google's AI blog, they present the video BERT model, a technique for aligning language and the video frames in videos that contain instructions such as how to roll a burrito or how to cook an omelet. And they use this kind of correspondence between the language and the prediction of the next video frames in order to better structure the unsupervised learning of representations from these videos. Because video data is so interesting because there's so much of it to use. So the way that they do this is they use an ASR, automatic speech recognition system, in order to transcribe the audio into language from the videos. Once they have the language tokens aligned with the video frames, they line them up like this, and then they use the same masking style that is used in BERT in order to predict the missing words and the missing frames. So overall, they show how you can test their model. You can give it some input text like season the steak with salt and pepper and watch the model output the frames that correspond with this language instruction, and then also you see the temporal coherence as the language sequence progresses from season the steak with salt and pepper to carefully place the steak to the pan, and you see how the model is learning the visual representations that correspond with these language tokens. And then also you see how you can see the model with a image and then have it fill out the future frames of the video it expects from that starter image. So it's a really interesting paper showing a new way of unsupervised, self-supervised representation learning from video data. Next from Google's AI blog is recursive sketches for modular deep learning. You may be really interested in sketches if you've ever used the intermediate features of convolutional neural networks for tasks like image-to-image similarity or neural style transfer. In image-to-image similarity, say we have a data set of different cat and dog images, and we want to find the nearest cat that, the cat that looks the most similar to another cat in our data set. One way of doing this is to see which other cat image has the most similar activations in the convolutional network after training the classifier on the cat versus dog prediction task. So this is also used in style transfer, where they take the intermediate activations from one image as the style, and then they use higher level features as the content for the other, and they combine them by using these intermediate representations from the convolutional network. So sketches are ways of reducing the storage size of these intermediate features of the convolutional networks so that you can form knowledge graphs from them and overall speed up image-to-image similarity and different applications like this. So if you're interested in checking out this paper, it's called Recursive Sketches for Modular Deep Learning. It's a full paper detailing the algorithm and motivating the application of it. The final blog post from Google's AI blog in this weekly update video raises interesting questions about how we evaluate automatically generated speech from systems like the Tacotron 2. So frequently in these speech generation systems, you evaluate them based on single sentences generated. But this article shows how if you add more context, such as having a full paragraph or restructuring the way in which you compare the generated speech with the natural speech, you'll get much different mean opinion scores from human reviewers. So this is shown in this chart. The worst mean opinion score is when you directly compare the natural text or the natural speech with the generated speech on like one line of natural speech followed by one line of generated speech, and this achieves the worst overall mean opinion score. Also achieving a notable difference is when you see if you evaluate the sentences in isolation, it's about 4, whereas if you give it the full paragraph, it's around 3.5. So overall, this blog post raises interesting questions about evaluating generative modeling. It's like things like evaluating speech on just one sentence or just one word, similar to evaluating like an image model on one image, or maybe just like one particular class of images. So it's definitely interesting to think about expanding the scope of the automatic evaluation of speech generation systems into entire paragraphs or entire news articles. Facebook's AI blog details their Fellowship Summit 2019 and gives 5 really interesting examples of awarded fellowships, which I think is really useful for getting a sense of what kind of research they're looking for, and overall to get a sense of how to guide your efforts if you want to apply for one of these fellowships, which they invite you to do at the end of the article. You just come here to the Facebook Fellowship Program and then apply for the fellowship. So the first one is building machine translation systems for monolingual corpora. So what this is unsupervised machine learning, machine translation systems. And this is really interesting. I had no idea of the success of this before I read this article. So basically the anecdote he gives is really powerful. What if you had a bunch of Chinese books and a bunch of Swahili books? How would you wouldn't be able to translate between these without any supervision or any human help. But his language model is able to do this in an unsupervised way. And not only that, but they're able to beat the best supervised machine learning machine translation system from English to German 5 years ago. They're able to now do that totally unsupervised without any labels of the translation or like paired sentences or different examples like that. So the next fellowship talks about using crowdsourcing to an AI to help combat the spread of misinformation campaigns. Really interesting, really definitely enormous impact application of AI. The next fellowship talks about the challenge of collecting digital medical image data sets in different environments. So this guy, he talks about his challenge in Ethiopia to collect the digital microscopic images of diseases in order to train the computer vision systems and use them to scale up the reach of doctors. The next fellowship talks about using human-computer interaction to improve wellness and a sense of wellness and interaction with different technologies. The final fellowship talks about same thing we just discussed from Google on understanding the world from videos, representation learning from video data, and his research and efforts, and overall just like why this is such an important thing and how having a sense of videos is so important for having systems that are able to interpret the visual world. Intel released a post detailing their quantized version of the BERT model to 8 bits. This is a really interesting article where they quantized the BERT model from the 32-bit floating point representations to 8 bits. With really, really small accuracy losses from doing this. So this is advantageous. Quantization, pruning, and things like model distillation are all techniques to reduce the file size needed to store these deep learning models and thus make inference and the practical application of these models much more useful and practical. So they describe their algorithm, they discuss the advancement in these language models to have enormous amounts of parameters, like how the BERT large model has 334 million parameters, and overall they show how their 8-bit quantization results in a 4 times reduction in the memory footprint of the BERT model. So they do this by converting 32-bit floating points to 8-bit, and they also discuss how they keep the 32 bits for certain operations like normalization and the softmax layers. So it's definitely interesting, the software-hardware co-design going on here, where you have some 8-bit general, the gem operations compared to some 32-bit operations like normalization and softmax. So in the article, they discuss the exact technique they use for quantization, how they implement it, how they release it into their NOP Architect library, how they start off with the Hugging Faces PyTorch transformations, and then they evaluate it on the GLUE General Language Understanding benchmark and the Stanford question answering data set, and show how their reduction in memory size doesn't really reduce, their 4 times reduction in memory size hardly reduces the accuracy of the resulting model at all. Intel also posted about the open sourcing of their NOP Architect library, which is where you can go find the quantized 8-bit transformer model. They talk about the different models they have in this library, different transformers. They have the quantized BERT, the 8-bit that we just discussed, and the reduction in model size. And they also have a distilled version of the BERT, similar to Hugging Face's post about distilled BERT, where they use the teacher-student model distillation example of using the pre-trained BERT model to compress its representation into a much smaller model. They also have an open source version of this that you can go get on GitHub. Overall, they talk about the future of the NOP Architect library and their plans for how they want to open source their language models through this GitHub repository. Salesforce Research blog introduced the conditional transformer language model for controllable generation that they denote CTRL control. So what this is a 1.6 billion parameter language model. So like these transformer models that produce long sequences of text, like OpenAI's GPT-2 or other models like NVIDIA's Project Megatron. This allows you to extend these models by influencing control codes that can control what is generated. So for example, starting from the prompt, a knife, you can embed the review control code to get something like a knife is a tool and this one does a job well, blah, blah, blah. And then you can embed the control code horror to get like a story, like a knife handle pulled through the open hole in the front. So these control codes, similar to things like how the style GAN is able to influence the generated images with different factors of variation, the control language model is able to do this with these language models. So this is also useful for understanding which kind of sources the different prompts from the transform. So when the transformer outputs some language, you're able to inspect the data set and see what caused it to come up with that kind of an output. So if you look at things like the talk to transformer model, you see when you type in prompts like a knife handle, you get these things like this, kind of like a review. So overall, the control language model, really interesting way of sort of having a control over what the language models are producing. Weights and Biases published another article detailing what their system is and how it can be used. So similar to last week where we covered how the Latent Space company is using Weights and Biases to develop generative modeling of 3D landscapes. This post discusses how Weights and Biases is used to iterate on a weather prediction model. So they start with the Deep Lab image segmentation architecture to complete their challenge, and they use the Weights and Biases framework shown here using the import Weights and Biases callback to iterate on their model and implement new things like reducing the learning rate and increasing the cost of the model for false positives. So it's a really interesting article just helping you get familiar with this new tool, Weights and Biases, that helps you to manage deep learning workflows and particularly to A/B test different tweaks to the model. Our coverage of NVIDIA's AI blog begins with the description of a system to automate medical coding. So the problem is basically after they have these interactions with doctors, they have this transcription of what happened, and then they code this to the different billing codes that are used to describe the interaction with the doctor according to like health insurance and different things like this. So they describe how there are more than 150,000 of these codes, and there's a scarce number of medical coders able to translate this. And additionally, it's a challenging problem because the doctors don't follow always the same template of describing their interaction, and also their handwriting can be messy, so it's challenging to design vision systems as well as the natural language processing systems that can automatically encode the transcriptions from the doctors into the medical codes. So discuss how they use things like the BERT language model and NVIDIA's GPUs on Google Cloud in order to build a system that can automate this task. Next from NVIDIA's AI blog is a really useful discussion explaining the differences between building your own GPU system in-house versus outsourcing it to using on the cloud, as well as a hybrid approach. So basically, if you have a GPU on the cloud, you're able to use much more resources and perhaps use something like a 8 GPU or an 128 GPU system much before you're really ready to have that in-house. And then if you have it, but you are going to have to pay more for using that many times compared to whereas if you build it in-house, the cost will scale much better with the amount of different times that you use it. So they also discuss using a hybrid model of having your GPUs where you maybe have like a local setup to run tests, and then when you want to scale it up to use different GPUs and maybe some kind of distributed training system, that's when you would go to the cloud. So overall, it's just an interesting discussion of the different options that you have with getting access to GPUs to accelerating your deep learning workflows. The next post from NVIDIA's AI blog discusses KiwiBots, a automatic navigation system to deliver food on the UC Berkeley campus. So in the blog post, which also has an interview from the NVIDIA AI podcast, the CEO of the company discusses how currently they're using remote workers in Colombia to do things like observe if humans are crossing the street to navigate the KiwiBot, and also sometimes to keep it on balance. But they're working on transitioning into using neural networks for the vision navigation as well as balancing the robot. So their system uses the NVIDIA Jetson TX2. This is an embedded system that is optimized for inference with deep neural networks and is also used in the our machine cognition and perception robotics lab at Florida Atlantic University. Also had a post about using the Jetson TX2 to build this RoboDog that was featured in NVIDIA's blog. So the Jetson TX2 looks like a really great way of building IoT devices and enabling things like autonomous navigation by using this kind of inference chip. The final post covered from this weekly update from NVIDIA's AI blog is about using automatic character recognition systems to digitize documents such that rather than taking an image of a scanned document, which you cannot search through, They use the OCR system powered by NVIDIA's DGX-1 system to scan the documents such that you have the language properly corresponded into a PDF, and then you can search through it. So they talk about the scale of the project, how many different documents they have, how much data is being processed, and overall different things about the company. From the MIT Computer Science and AI Lab is a system on using machine learning to estimate the risk of cardiovascular death. And what's really interesting about this system called Risk Cardio is that it just uses the first 15 minutes of a patient's raw ECG signal rather than using all sorts of metadata and different things like this. So contrastingly to Google's differential diagnosis of skin condition blog post and paper that we looked at earlier in the video that shows a clear improvement using the metadata, this ECG reading isn't going to bother with the metadata. So it's definitely interesting to see the little differences across different machine learning and healthcare applications. So what they are doing is they're just reading this raw ECG system, and they talk about some of the challenges of this, like how you need long-range dependency modeling. So similar to how the original recurrent network was expanded with the LSTM and then the transformer, you can expect these kinds of long-range dependency modeling improvements to also improve things like reading ECGs to estimate the risk of cardiovascular death. So they discuss how their system results in a 7 times improvement over the previous system, and how they train their system with the labeled pairs of risky and normal heartbeats. This week's edition of The Batch begins with a note from Andrew Ng, which is a warning heed to different companies that say that they might be underestimating their strategy for AI, similar to how the internet revolution, some people just built a website and didn't anticipate things like the interconnected mobile apps that would transform ride hailing. So in The Batch, they go on to talk about autonomous warfare and the different sides of the stands, things like the development of Skyborg and AI Copilot for F-16s, self-driving assault boats, and the Sea Hunter. And overall, they discuss how they need AI systems in the military to respond to things like hypersonic missiles that travel really fast, and they don't have that much time to respond to them. So overall, the batch concludes with a discussion on how they have to encourage a ban on autonomous weapons as a complement to nuclear disarmament in the United Nations. So following this is a discussion on the what language models know, and a reaction to the Allen Institute's success with the BERT model on the 8th grade science test. So basically the Llama language model analysis task is about seeing if off-the-shelf language models can perform task-specific tasks and outperform models that are fine-tuned on these tasks, like things like filling in the blanks or the SQuAD question answering data set. So they do find that the large pre-trained models can almost just already perform most of these tasks without too much fine-tuning. Following this is the use of facial recognition and these bounding box detectors to recognize different chimps and track them as they grow older. So it's definitely interesting to see the high accuracy of this. The model is able to get 84% compared to humans who can only get 42%. And overall, it just shows how it's better than things like RFID animal tagging to do things like wildlife preservation and these kinds of applications. Following this is a discussion of the deepfake challenge from Facebook. So they funded with a $10 million grant. They're working on building a data set to detect these kinds of deepfakes when they morph the faces of actors, and they do miscellaneous things that make videos appear real and make people say things that they haven't actually said. So also from this post from the batch, they link you to this guessing game, which is pretty interesting, where you pick which face is real. And as you play it for several iterations, it's actually pretty challenging to see which face is real. So following this is the Sabre paper, where they are trying to standardize the benchmarks for the Atari games and have a more standard set of metrics to compare different reinforcement learning algorithms. So they discuss miscellaneous different things they do to standardize the Atari benchmarks. Following this is a discussion about automation in fast food and a trend overall towards automating things like kiosk and delivery, more so than the construction of the food, like the assembly of the pizza in this robot. So it's definitely a pretty interesting thing to keep an eye on, is the development of automation in fast food. Thanks for watching the AI Research Weekly Update, September 15, 2019 from Henry AI Labs. Please subscribe for more deep learning and AI videos.